So 8.1, samples and populations. Sample needs to be representative of the larger population. So we're going to look at different kinds of samples, the ones we want, the ones we don't want. And it starts out with some terms and definitions. Okay, population is an entire group of people or objects. A sample is a part of that population. So it might not be possible to ask every single person within a population. For example, do you know how many people roughly live in the city of Jacksonville?
3 million. 2 million.
A million. A million.
Wow.
So if you want to take a survey and ask the citizens of Jacksonville something, it would be kind of tough to ask 1 million people a question, just one simple question. So instead of doing that, you can take a sample. But that sample needs to be representative of the population. Okay? So, population, entire group, sample is part. An unbiased sample is representative, and here's why. It's random, and it's large enough to be accurate. So if it's 1 million people, do you think it's going to be accurate if I ask 10 people to represent the million? No. I mean, you've got to ask a good chunk of them, like 100,000, right? So it's got to be large enough for accuracy. You say, well, it was random. Oh, it's 10 people. Well, no, it needs to be more than that. So it has to be both. It has to be random and large enough for accuracy compared to the population. All right. Now, if the population's 100 people, maybe 10 is close-ish. I would say maybe a little more would be better. So then we kind of come down to this second type of sample, a biased sample, one that you want to avoid. Biased samples do us no good. Okay? They don't give us accurate information. So a biased sample is what we want to avoid. It's not representative of the population because one or more parts of the population are favored. So if I wanted to get a perspective of the citizens of Jacksonville on any certain topic, but I only asked the West Siders, West Side people, where I'm at, yeah, right? But I don't ask the North Siders or the South Siders. Would you agree that we're all kind of different, right? In different parts of town, right? So in order to get an accurate picture, I have to ask people from all parts of Jacksonville, not just a certain part of Jacksonville. So that would be an example of a biased sample if I only ask people from a certain side of the city, okay? Or if I only ask 15-year-olds a question or a certain age. I mean, it could be any number of things. It has to be random and it has to be large enough for accuracy. All right, so that really in a nutshell is what we're doing today. We're just going to look at different scenarios and determine, is it biased? Is it unbiased? Why? Why not? Which one should I pick? And that's pretty much it. There's not a whole lot of math that's really going to go into today's lesson, except one little part of it in example 3, and we'll get to that in just a minute. All right, next slide. Okay, you do not have to write all of this down. It's right there in your books in section 8.1, but I do want you to answer the question, so that you will write down underneath example 1. We are trying to identify which sample would be unbiased, okay? So we're going to kind of approach this in reverse and eliminate the options that are clearly biased, okay? So they're not going to be the ones that we want to use. Here's your scenario. You want to estimate the number of students in a high school who ride a bus to school. Which sample is unbiased? So that's my question, but in reverse, I want you to tell me which one of these options, 1, 2, 3, or 4, would be clearly biased or not representative of the population. Which one do you think would not be a good one to pick? Zach? Okay, you would say number 3, 50 12th grade students. Why would you say that one is a no?
Because what about 11, 10, and 9?
Yeah, so you're only focusing on a specific grade. So essentially what you've done now is you've only asked a certain part of the population. That makes it biased. So that one's out. What's another one that would be definitely out? Jason?
Number 2.
Number 2, all the students on the soccer team. Why would you say that one's out?
Because they're
Yeah, again, it's a certain part of the population. It doesn't represent all the students. You're asking students that are in a certain club or on a team. Definitely out. And then what's the last one? Actually, probably the most obvious one that's a no. Miles? Yeah, number 1. Why is that one out?
It's just the kids in the hall.
It's 4 kids. How can 4 kids represent the entire high school? Okay? So clearly our option by process of elimination is option number 4. It's 100 students. They were selected at random during lunch. All the grade levels are represented during lunch. Let's pretend that we don't know who's in what grade. All right, that would give us the most accurate sample possible. All right, so that's number 4 is what I would choose. All right, now let's kind of start over on these options. What if now you want to estimate the number of 12th grade students in a school who ride the bus? Which sample now would you choose out of 1, 2, 3, and 4? Someone raise your hand. Give me, guess the same people-ish. Kyle?
3.
Why would you choose number 3?
Because it's 50 12th grade students that are reading.
So now the question is specifically targeting 12th grade students. So number 3 would be the most obvious fit because those are also 12th grade students. So it gives me a really good picture. Right? Any questions on that? You see what we're doing here? Okay. That's it for example 1. All right. I want you to read this scenario. Again, you don't have to write the whole scenario. It's right there in your book. But I do want you to answer this question. Would it be number 1 or number 2? And why? Which one is unbiased for this scenario and why? All right, what you think, Sarah? Right. So the fact that number 1, it said specifically members of the band, that's your immediate indicator. That's not accurate because that's only like one group. Okay. So number 2 definitely is my choice because it's every 5th student. It's random, alphabetical. There's no pattern to it, and I can get a better picture. Okay, you see that kind of obvious differences there? All right, so example 2. Now we're determining whether or not conclusions are valid. Okay, so let's look at these 2 examples. It says you survey 100 residents who live closest to the new. I'm sorry. Let me back up. You want to know how they feel about adding a new landfill to the area. What is a landfill? What's a landfill? That's where you dump all your trash. Okay. Anybody ever think like in your house, oh my goodness, that stinks so bad. Let me just throw it in the trash and take it out. Right? That goes somewhere. It goes to a landfill. So they normally don't smell very good because that's where you keep all your trash. All right. So you want to know how the residents of your town feel about this new landfill. Okay. So you survey 100 of them. Here's scenario 1. These 100 residents live closest to the new landfill, and Table A shows the results. Clearly, only 10% support the new landfill. Is this conclusion valid? I want you to think about it. Specifically, well, I'm going to hold back on that hint. Do you think this conclusion is valid from Table A? Scenario number 1. Valid? Note where they are located. Where are these 100 residents living? Right by the landfill. They're the ones that get to smell it in their backyard every day. Maybe they had a beautiful swing that they just built in their backyard. You think they want to go out there now? No. Right? So they're probably going to be really unhappy with the new landfill because it affects their everyday lives. So this result is skewed to the negative. Now, it might still be negative overall, but do you see how that would be biased? Because you only ask the people who live closest to the landfill. So, not valid, okay? So you would say, no, it's not valid. Wrong. There we go. So, not valid. Scenario 1, not valid. Because it's not random, right? Or you could say only ask people who live closest to the landfill. Only people closest, not people all over the town. Were surveyed, okay? All right, something along those lines. All right, we're not going to be super picky with it, but we're recognizing that only a certain part of the population was asked. So in scenario 2, now you survey 100 residents at random. Maybe you go to the different grocery stores around town or something. So table B shows those results. And then you make the conclusion 60% of your town does not support it. Is that valid?
Yes.
Okay, yeah, it is. Okay, it's as valid as it possibly could be without asking every single person in the town. All right, which would not be reasonable. Yes, because it's random and large enough to be accurate. And large survey, okay? That's the 2 criteria, guys. It's got to be random and it's got to be large enough to be accurate, okay? Maybe we'll just say it's a small town, right? Okay, so that's example 2. All right, example 3 gives us a pie chart. I apologize for the size of the font. I really fought with this pie chart, actually. Kept trying to give percentages, and I needed to give the actual amount. All right, so here's the scenario here. You survey 75 students to see how many movies they watch per week. Okay, so let's take a quick survey of this class. Per week, so let's say Sunday to Saturday, how many of you would say, I don't watch any movies at all? 0. How many of you would say 1? How many of you 2 or more movies? It could be the same one over and over again. That counts. Okay? All right. I think I've seen Moana 53 times. All right. So, seriously. Okay. So now there are 1,200 students in the school, and you want to estimate the number of students in the school who watch 1 movie each week. Okay. So what you're going to do is you're going to create a ratio based on the pie chart of how many students in the sample watched 1 movie per week versus the total number of students who were surveyed in the sample. Okay? So according to the pie chart, and this is what you need to write in your notes, how many students, according to the sample, watched 1 movie per week? 30. Okay? Out of how many were surveyed? 75. Okay? So part over the total equals, I don't know how many students in the general population out of how many total students are we talking? 1,200. Okay? So assuming that my sample is accurate, and guys, this is what it all comes down to. Okay? This is where it all needs to come together for us. Why in the world do we take a sample in the first place? It's so we can have an accurate picture of some larger group that we could never possibly survey. Or it will at least take us a ridiculous amount of time to ask a simple question. All right, so we're going to use that percentage to make a prediction on a larger total. We need to use what method?
Cross products.
Cross products. Okay. Cross products to solve 75 times S and 30 times 1,200. 75S equals 36,000.
Oh, that's an S.
Divide. Yeah, S for students. Sorry. What? Guys, come on. That's an S. S for students. Oh, come on. 36,000 divided by 75. You guys are too hard on me. That is clearly an S. I'm very proud of that S. This is a 5.
The 5
Yeah,
is
but
straight
there's
line.
like a straight line.
Come on, guys. Okay, are we all on the same page now?
Yes.
Okay. What is 36,000 divided by 75?
480.
Okay. So what I'm saying is S, number of students, should be about 480 students who watch 1 movie per week. Based on the sample. Now, if I really asked all 1,200 students, it might not be 480 exactly, but if my sample is representative of the population, it should be really close. Close enough that I could use that data. Okay? All right, makes sense? You guys heard of like approval ratings for like politicians and that type of thing? That's where this comes from. They take a sample survey and they use that survey to represent the population. Harvard comes out with a lot of these polls and surveys and whatnot. Nobody's asked me what my opinion is, but I know that they put these surveys out there. All right? So if you understand that, that's everything you need to know for 8.1.